Thank you for coming back to join me on page 13. On page 12, we started talking about that particular function, and we found the pre-calculus information and some information about the derivative. Page 13, we're starting to talk about second derivative information. Again, same thing happened on this one. The hover cam froze, so I had started to write part of this, and I'm not going to rewrite it. So again, I'm saving us some time in giving you the second derivative, which you would have to do a quotient rule on f prime of x. Here's what f double prime comes out to be. And just like for the first derivative, we'll need to look where f double prime is equal to 0, where f double prime of x is undefined, and where f double prime of x does not exist. F double prime of x equals to 0 is going to happen when the numerator is equal to 0. So if we just look at that 4 could never equal 0. But 3x squared plus 1, if we set that to 0, x squared would have to be negative 1/3, which is not possible. You can't square anything and get a negative number, so none here. F double prime undefined. Again, where the denominator is equal to 0, and that's coming up with x equals plus minus 1, and does not exist, are piecewise functions, which we don't have, so none there. Same thing happens in this case, though. While f prime equals 0, undefined, does not exist, sets up relative extrema, f double prime equal to 0, undefined, does not exist, sets up our possible points of inflection. But the same issue happens here with these guys. These are not possible points of inflection because they're not in the domain of f of x. Okay, so actually we aren't going to have any points of inflection here. There won't be any. Now, to do the graph, to set up this table, we are going to want to, for the intervals here, we want to use all the zeros, undefined, and does not exist for f, f prime, and f double prime. And that's really only, let's see, from the original function, we didn't have any zeros, but we do have some undefineds here. Those are your vertical asymptotes at plus or minus 1. Okay. Is that it? Oh, and then our critical number of x equals 0 over here on f prime. So that's it, just 0 and plus or minus 1. That's 3 times 2, 6 plus 1, 7. So we'll have 7 intervals here. X less than negative 1, x equals negative 1, at 0, x between 0 and 1, at 1, and x greater than 1. 1, 2, 3, 4, 5, 6, 7. Okay, now I am going to pull this function over here, the original function, so that you can see it when we set up this table. So we're going to complete the f of x column right now. We're going to do all of that information first. So on the f of x column, we just start, we know at x equals negative 1, this function was undefined. That was a vertical asymptote. At x equals positive 1, the function is undefined. Another vertical asymptote. At a nice specific value, when x is 0, we had negative 1 here. All right, the rest of these are interval places. So we need to do some sign analysis. If I look at this thing here, this numerator is always positive. So all I really need to concern myself is the sign of the product of the denominators. So if I choose something smaller than -1, say -2, and I put a -2 in here, -2 in here, that's negative, and a -2 in here would be negative. So I have a negative times a negative, which is overall positive. If I choose a number between -1 and 0, say -1/2, -1/2 plus 1, that's positive. -1/2 minus 1, that's negative. So we have a positive times a negative is negative. Between 0 and 1, say 1/2. This is positive times negative is negative. And x greater than 1, say put a 2 in here. We'll have positive times positive, which is overall positive. Now, what do those signs of f of x tell us about the graph of f of x? It tells us if the graph is above or beneath the x-axis. So right here, this is above the x-axis. We knew we have a vertical asymptote here. This is below the x-axis. This is the y-intercept. This is below. Another vertical asymptote. And above. Whew. All right, let's go get the first derivative information. Now, I'm putting my first derivative over here so that we can use this to figure out the sign analysis that we have. Let's see, we knew at x equals 0, f prime is 0, so I'm going to fill that in. I do know at x equals -1, f prime is undefined, and at x equals +1, f prime is undefined. Okay, now, signs again. If I look at this, f prime, the denominator will always be positive. So all I really have to worry about is the sign of the numerator. So let's choose something smaller than -1, say -2. Multiply it by a -4, that becomes positive. Between -1 and 0, say -1/2 times a -4, that's positive. Let's see, between 0 and 1, say +1/2 times -4, that's negative. And greater than 1 times a -4, also negative. F prime then tells us about f of x increasing or decreasing. So f prime positive means f is increasing. We got an asymptote, so there's nothing you can say here. We got another increasing horizontal tangent, decreasing vertical asymptote, so nothing there, and decreasing. Okay, looking at this horizontal tangent, the graph is changing from increasing to decreasing, which means that that horizontal tangent is a relative max. Okay, last one here, let's look at f double prime. And conveniently, f double prime is on this page, right up here. And again, I'm interested in signs. I don't have anything that's equal to 0. I do have an undefined at plus or minus 1. All right, so the numerator is always positive. So I don't have to worry about that. I just need to worry about the denominator. And let's see, let's put something smaller than -1 in here. Say -2. Put a -2 in here, square it. That's +4 minus 1 is 3. 3 cubed, positive. All right, let's do this one. Between -1 and 0, so -1/2. -1/2 squared is +1/4 minus 1. I don't care what it is, but it's negative. And then negative cubed is negative. 0. Oh, I can get the actual value there. But again, all I'm really interested in is sign. 0 squared, 0 minus 1. It's -1 cubed. That's negative. +1/2. 1/4 minus 1. That's negative. Last one, put a 2 in here. 4 minus 1 is 3 cubed, positive. And F double prime tells us about concavity of F. So we have a concave up. Here F double prime is negative, so F is concave down. And the last one, F double prime is positive, so this section is concave up. No points of inflection. We definitely have change in concavity here and here. However, in order for there to be a point of inflection, there would have to be a tangent line here. There is no tangent line. There's a vertical asymptote there. There can't possibly be a tangent line on an asymptote. Okay. Let's go ahead and sketch this graph. I am going to use a straight edge here and try and be as accurate as possible. All right, we have vertical asymptotes at x equals -1 and at x equals +1. So I'm going to go ahead and put those vertical asymptotes in. From the previous page, we had a horizontal asymptote at y equals 1. I'm going to put that in. We have a y-intercept at 0, -1. Okay, now we just start looking. When x is to the left of -1, we want to be above the x-axis, increasing, concave up. Now, and you have to deal with these asymptotes too. So above the x-axis, increasing, concave up. Something like that. And we have this vertical asymptote at x equals -1. Between -1 and 0, the graph of F is below the x-axis. It's increasing and concave down. Below the x-axis, increasing, concave down, coming into a horizontal tangent and a relative maximum. So coming in that way, horizontal tangent sitting right here. Coming out of there, we're below the x-axis, decreasing, concave down. Vertical asymptote at x equals 1. When x is greater than 1, again, above the x-axis, decreasing, concave up. And it's right there. And there's your final graph. Ages and ages and ages ago, when I was in calculus in the last century, we didn't have graphing calculators. So every time we needed to sketch a graph, we did all of this. Every time you needed to sketch a graph, we got really good at tables and asymptotes and finding information pretty quickly so that you didn't take too long graphing. So enjoy the timeline that you are living in with the graphing calculators, and just imagine what your kids will have when they take calculus. Have a wonderful day. Thank you for listening.